Welcome to the deep dive. Today, we're digging into something called powder metallurgy components.
Right. It might sound a bit technical, but honestly, it's everywhere.
Exactly. Think cars, electronics.
Hmm.
It's pretty fundamental. We're using a market report here from Cognitive Market Research. It's called the Global Powder Metallurgy Market Report 2025.
Yeah, it gives a really good snapshot. Our goal is basically to pull out the key stuff for you to figure out how big this market is, where it's going, and what's really driving it.
Think of it as the Cliff Notes version of a pretty dense report.
Precisely. Saves you wading through it all.
And just to give you a feel for the scale right away in 2025, the global market, it's expected to be around 2.6 billion US dollars.
Okay, 2.6 billion. That's already substantial.
But wait, here's the kicker. By 2033, they expect that to jump to almost $7 billion.
Wow, nearly 7 billion. That's more than double in just 8 years.
Mm-hmm.
What's causing that kind of, explosion?
So the report points strongly towards electrical and electromagnetic applications. That seem to be a huge driver.
Ah, okay. Makes sense with electrification trends.
Totally. And this demand is fueling what they call the AGR compound annual growth rate. Basically, the average yearly growth. It's projected at 13.20% between 2025 and 2033.
13% year-on-year average. That's very, very healthy growth. It's definitely not a sleepy industry.
Not at all. Okay, so let's break it down. Where is all this happening? Let's look at the regions.
Right. So currently, North America is the big one. They hold the largest slice of the pie. Over 40%, actually.
Over 40%. Okay.
Yeah. In 2025, their market size is estimated at about $959 million. And they're expected to grow at about 11.6% per year through 2033.
And within North America, I assume the U.S. is the giant.
Absolutely, yeah. The U.S. market alone is pegged at around $757 million for 2025. Similar growth rate, too, 11.4%.
And why is the U.S. so dominant there?
Well, the report mentions the strong automotive manufacturing base, plus, a long history of tech innovation. Those seem to be the key factors.
Okay. What about Canada and Mexico? Are they significant players, too?
They're smaller, but definitely growing. Canada's looking at maybe $115 million in 2025, but with a slightly higher growth rate, actually 12.4%.
Yeah.
Again, tech advancements seem key there.
Interesting, 12.4%.
And Mexico, around $87 million in 2025, projected to grow at 12.1%, likely benefiting from, that expanding manufacturing sector.
Got it. So North America is leading strong growth across the board. Let's hop across the pond to Europe. How does it look there?
Europe's another major hub. They hold over 30% of the global market. That translates to about $752 million in 2025.
You're on their growth rate.
Projected average yearly growth is 12.2%, so pretty strong as well, just slightly higher than North America overall. And several countries are, big contributors.
Like who? Give us a couple of the main ones.
Sure. The UK, for instance, is projected around 126 million in 2025, and their growth is actually quite strong, 13.0%. Tech advancements cited there, too.
13%, wow.
And then there's Germany, of course. Big automotive industry influence. They're looking at about 149 million in 2025, growing at 12.4% annually.
Okay, Germany makes sense. Any others worth mentioning?
Yeah, France, Italy, Russia, Spain, they all have pretty substantial markets. France is around 69 million, growing at 11.4%. Italy, about 65 million, 11.6%.
And Russia?
Russia's quite large, actually, around 117 million, though the growth is a bit lower at 11.2%. Spain's about 62 million, 11.3%.
That's a broad base in Europe.
Definitely. And it's not just the big economies. You see consistent growth forecasts for places like Sweden, Denmark, Switzerland. Yeah. Even Luxembourg shows strong potential with a 12.5% projected CEGR.
Right. So Europe is solid, maybe slightly more varied growth than North America. But I get the feeling Asia-Pacific might be where the real action is heating up.
You absolutely hit the nail on the head there. APAC currently has about 23% of the market. That's around 622 million for 2025.
Okay. Smaller share than Europe and North America right now.
For now, yes. But here's the thing. Their projected annual growth rate is a whopping 16.1% between 2025 and 2033.
16%. Okay, that's significantly higher than the other regions.
It really is. That signals some major shifts in development coming in the next decade.
So which countries are driving that incredible APAC growth?
Well, China is a huge factor, as you'd probably expect. Their market's estimated at over 261 million in 2025, growing at 15.6% annually.
What's fueling China's growth?
The report points to, the usual suspects.
Yeah.
Rapid industrialization, ongoing urbanization, just massive economic development overall.
Right. And besides China?
Japan and South Korea are also significant markets, both with strong growth rates too. Japan around 86 million, growing at 14.6%. South Korea about 75 million, growing at 15.2%.
Okay.
But the real standout, maybe surprisingly, is India. Their 2025 market is smaller, around 62 million, but the projected annual growth rate, 18.0%.
18%. That is enormous. Any idea what's behind that specifically in India?
The report doesn't dive super deep into the country specifics for India, but typically in these fast-developing APAC economies, it's often a combination of, booming manufacturing, big infrastructure projects. Things like that tend to drive demand for these kinds of materials.
Makes sense. An 18% CAGR is definitely something to watch. Okay, let's round out the globe. What about South America?
South America accounts for a smaller piece, just over 5% of the global market. That's about 98.5 million in 2025. But their growth is solid too, projected at 13.9% annually.
And the main players there.
Brazil and Argentina lead the pack. Brazil's around 42 million, growing at 14.5%, likely driven by demand for, high-performance materials. Argentina, about 16.5 million, growing even faster at 14.8%, probably helped by their automotive sector.
Okay. And lastly, the Middle East and Africa.
Yeah, these regions have the smallest shares, currently Middle East around 2%, Africa around 1%. But again, don't count them out on growth.
Right. What are the growth numbers like?
The Middle East is projected at 14.6% annually, which is quite high. Key markets there are Saudi Arabia and the UAE.
14.6, yeah, that's up there.
Africa, starting from a smaller base, about 57 million in 2025, is expected to grow at 13.5% per year. South Africa and Nigeria are the ones highlighted.
Okay, so yeah, it really is a dynamic picture. North America leads now, but APAC, especially India and China, are growing incredibly fast. Europe's solid, and even the smaller regions show strong potential.
Exactly. It's shifting.
All right, let's switch gears a bit and talk about the actual stuff, the materials. The report breaks it down by metal type, doesn't it? Ferrous and non-ferrous.
That's right. Primarily ferrous, meaning iron-based metals and non-ferrous. And in 2025, ferrous metals definitely dominate the market.
Why is that?
It really comes down to their properties. They offer great mechanical strength, hardness, good magnetic functionality. They're quite flexible, just really well suited for a lot of demanding applications.
Like in cars.
Exactly. Think engine components, transmission parts, chassis elements. That's where ferrous powder metallurgy really shines.
And is that dominance expected to continue? Is ferrous still growing?
Oh yeah, demand is still expected to grow. The report projects about 5% growth between 2024 and 2029 for ferrous parts. There's still a huge need in construction, engineering, and especially automotive.
Okay, so ferrous is the established leader, still growing steadily, but the report flagged non-ferrous metals as the fastest growing segment. What's the story there?
Yeah, that's a key point. Non-ferrous metals, we're talking things like aluminum, copper, tungsten, nickel, and others.
Right.
They're becoming crucial where things like lightweight construction, high electrical conductivity, or corrosion resistance are really important.
So different applications than the typical ferrous uses.
Often, yes. Think aerospace weight is critical there. Electronics conductivity matters. Medical, implants, corrosion resistance, and biocompatibility.
And why the rapid growth now for non-ferrous?
It's largely down to advancements in the technology itself, how the powders are produced, how they're processed. We can achieve much better results now.
Like what kind of results?
Well, for example, newer techniques allow for much finer grain structures in aluminum alloys made via powder metallurgy. This significantly boosts their strength-to-weight ratio, which is, a game changer for aerospace applications.
Ah, interesting. So better tech is unlocking more potential for these non-ferrous metals. While iron holds the fort, the others are really gaining ground. Okay, let's connect the materials to the end uses. Where are all these components actually going? The report talked about applications, and automotive seemed like the big one, right?
Absolutely correct. In 2025, the automotive sector holds the largest share by far.
Why are they used so much in cars?
Powder metal parts are just incredibly versatile for automotive. They're used in engine parts, transmissions, chassis components, really all over the vehicle.
What makes them so attractive to car manufacturers?
Several things, really. You can make really complex shapes with high precision, which is often needed. It's cost-effective, especially for high-volume production.
Right.
Plus, you can actually control the porosity of the metal. That's useful for things like self-lubricating bearings. And maybe most importantly today, it's quite sustainable.
Sustainable. How so?
Because the process often creates parts very close to their final shape. It's called net shape capability. This means there's much less material waste compared to, say, machining a part from a solid block. high material utilization.
Gotcha. Less waste, better for costs and the environment. Now, besides automotive, aerospace came up as another key area and fast-growing too.
That's right. Aerospace is pegged as the fastest growing sector for powder metallurgy applications.
And the driver there is?
It's that constant push for materials that are both lightweight and incredibly strong. They need to withstand really harsh conditions in aircraft and spacecraft. Powder metallurgy lets engineers design complex shapes and achieve specific material properties needed for things like turbine blades, structural parts, special fasteners.
Makes sense. Lightweight strength is the holy grail for aerospace.
Okay, so cars and planes are big. Where else are these powder metal parts hiding? The list seemed quite long. It really is diverse. The report mentions transmission parts like gears and synchronizers, oil bearings, clutch plates, then lots of engine parts, oil pumps, water pumps, VVT components, sprockets, pulleys, crankshaft bearing caps, sensor rings. It goes on.
Wow.
Also, chassis parts like shock absorbers, steering components, even parts for turbochargers and exhaust systems, plus electrical components like those sensor rings for ABS brakes.
Okay, so automotive is huge, aerospace is growing fast. What about outside of transport?
Oh yeah, medical devices, industrial machinery components, parts for power tools, even mining tools, electrical and electronics applications too. It's genuinely widespread.
It really is quite amazing. Okay, we've covered regions, materials, applications. Let's try and pin down the core reasons for this overall market growth. We touched on some, but what does the report explicitly call out as the main drivers?
It boils it down to three key things. First, the big one, the surge in electric vehicles, EVs. That's really fueling accelerated growth.
Right, the EV connection.
Second, that growing demand in the aerospace industry we just discussed. And third, just the generally increasing adoption across various electrical and electromagnetic applications.
How exactly does the EV surge drive powder metallurgy demand?
Well, EVs have a huge need for lightweight components to maximize range, and also for high-performance magnetic materials used in electric motors and associated electronics. Powder metallurgy is really well suited for producing complex magnetic cores with tight tolerances, often better than traditional methods.
Ah, okay. So it hits both the lightweighting and the electrical performance needs of EVs. Now, on the flip side, are there things holding the market back? Any restraints?
Yes, the report mentions two main challenges. One is the pretty high initial cost. Setting up a powder metallurgy facility requires significant investment, which can be a barrier, especially for smaller companies.
Right, the capital investment.
The other is that the process itself still has some technical limitations.
Yeah.
You can't make everything this way, or there might be constraints on size or certain properties compared to, say, forging or casting in some cases.
But it sounds like the industry isn't standing still. Innovation is happening, right? What about market trends?
Exactly. Innovation is a huge trend.
Yeah.
Companies are constantly working on improving the process, like getting better compaction efficiency for the powders, making denser, stronger parts. And there's a big focus on developing more sustainable, greener manufacturing solutions too.
Sustainability again.
Definitely. And another key trend is strategic partnerships. Companies are teaming up to expand what they can do, share technology, or reach new markets.
Does the report give examples?
It does. It mentions Aerosteel introducing something called Blue Tap Max back in July 2023. That's a high-performance powder metal steel specifically for making cutting tools like taps.
Okay.
And also Sumitomo Electric Industries setting up a new sales company in India in February 2023, specifically to boost their cutting tool sales. They're likely tapping into that high growth we talked about.
Right. Good examples of innovation and market expansion strategies. So with all this activity, who are the main companies battling it out? What's the competitive landscape like?
It's described as highly competitive, which you expect with this kind of growth. You've got a mix of big global corporations and some strong regional players as well.
And who are some of the heavy hitters mentioned?
The report lists several key names that dominate through, their broad product portfolios, strong distribution networks, and continuous innovation. Companies like GKN Huygens,
Okay, I've heard of them.
Sumitomo Electric, American Axle Manufacturing AAM, Miba AG, Hitachi Chemical, Fine Center, SHW AG, Stackpole International.
Quite a few well-known names in manufacturing and materials.
Yeah, and others like Arcam, now part of GE Additive, Carpenter Technology, Schunk Group, Porite Group, HC Stark, SMC Powder Metallurgy, Metaldyne Performance. It's a solid list of established players driving the market.
So a competitive field with some major forces shaping the industry. Okay, let's try and wrap this up. We've covered a lot of ground. What are the main takeaways from this deep dive?
I think the biggest points are, first, this powder metallurgy market is definitely on a strong upward trajectory. Serious growth ahead.
Driven mainly by.
Primarily automotive, especially with the EV boom, acting as a major catalyst, and also aerospace. Those seem to be the key demand drivers.
Regionally?
Regionally, while North America is the current leader in market size, keep a very close eye on Asia Pacific. That's where the most rapid expansion is expected, particularly in places like China and notably India.
Right. And we also saw that dynamic with the materials themselves, the established ferrous metals versus the faster-growing non-ferrous ones.
Exactly. You've got the continued importance of iron-based powders for traditional strengths, but this rapid growth in aluminum, copper, nickel, etc., for lightweighting, conductivity, and other specialized needs. It really shows how the field is evolving.
It paints a picture of a really dynamic industry adapting to new demands like electrification and pushing the boundaries in areas like aerospace.
Precisely.
So, thinking about all this, here's a final thought for you, the listener, to chew on. Given these strong growth trends, especially driven by EVs and aerospace, what might be the next big leap in material science within powder metallurgy? What new applications could emerge, or what novel combinations of materials might we see as engineers try to push performance even further in these expanding sectors? It feels like a space with a lot more innovation still to come.
Definitely a field worth watching.
Indeed. Well, thanks for joining us for this deep dive into the world of powder metallurgy components.